understanding, we're going to do covalent bonding. What is covalent bonding? How does it take place? Covalent bonding. Well, we know in covalent bonding, atoms, elements share electrons. Like instead of them giving charges, they share electrons. So what happens is that this atom would share with this atom here, and they would both share, and they would form 8 on the outer shell. So that's the whole idea of so if this has 6, 1, 2, 3, 4, 5, 6, and this has 6, 1, 2, 3, 4, 5, 2, 3, 4, 5, 6. So one has 7, this has 7. And they come together, they actually form 8. This counts as each one share, and this one says 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to do some examples now. So this is how it works. Let's say you have a molecule. Usually in covalent bonding, they give you the substance, because covalent bonds, they are like millions of bonds can take place. Like amino acids in the body, there's like 31 million proteins, stuff like that, 21,000 proteins. So it can form all kind of bonds. So in covalent bond, they will just give you the compound. How would this bond take? How do you get H2O? Well, what would happen is that you have to check the amount of electrons for each. So hydrogen has a +1 charge. So hydrogen is +1. The check the one total. So hydrogen is +1, and oxygen is 2-. So oxygen is no, you don't check that. You don't check charges in covalent bond. You check the amount of electrons in the outer shell. So hydrogen has 1 in the outer shell, and there's 2 hydrogen. So 1 electron plus minus 2. Oxygen has 1, 2, 3, 4, 5, 6. Oxygen has 6 electrons in the outer shell of 1 oxygen, which is equal to 6 2s are 12. With 1, 2 is 2 electrons, and so 6 electrons. So the total amount of electrons is 6, 7, 8 electrons. So what you do is you take the 8 electrons, which has 2, so 6. So what you do is you have to distribute these 8 electrons among the structure. So you take the one that would have the least to bond with, in this case, one that will form a bridge. Like hydrogen is one that only needs 1, so it's not gonna think from both sides. This one is the reaching one goes on the outside. So hydrogen would just need to pull 1 electron away from it. Unlike oxygen, right? So oxygen, on the other hand, will have both sides. So that way the oxygen goes on in the middle. So you write oxygen in the middle, and you write 2 hydrogen on the side. Right? So what you think is you try to find octane, you try to find the bond between both of them. So you have 8 in total, 6 and 2, 8. So you have 8 electrons to work with. So what you do is you take 2 here, 2 here, so you can form a bond. These 2 share. So you're down to 6 electrons. So you distribute them evenly. 1, 2, 3, 4, 5, and 6. So in total I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So it doesn't form a bond. So what you do is you take 1 from here and take 1 from here. So you get 1, 2, 3, 4, 5. 2, 3, 4, 5. If you take 1 more from here, you have to get 8 in all. So oxygen, hydrogen, you take 1 from here, you take 1 from here. Right, you want to form 8 in all. So you take 1 from there, 1 from there. One from there, so you get you get 1, 2, with 1, 2, and then you put next 2. So 1, 2, 1, 2, and then the 2 in top remain. So now you get this type of bond. Remember, hydrogen only needs 2 to be stable, right? Oxygen has how much? 6. So oxygen needs 2 more. You have to remember that. You have to remember the amount of hydrogen needs to be stable. So hydrogen doesn't need these 2 over here, but the oxygen does need 2. So oxygen does need 2. So oxygen has 1. So you just have to draw the 6 in the hydrogen. So hydrogen is 1, 2, 3, 4, 5, and 6, right? Hydrogen only needs 1. So hydrogen would bond here and bond here. That's it. That's the bond. Because now you have 1, 2, 3, 4, 5, 6, 7, 8 for oxygen. Hydrogen has it too, and it has it too. And that's it. That's how you that's what happens during a covalent bond between 2 hydrogen and 1 oxygen. So hydrogen covalent bonding, anything can happen. Any type of bonding can take a lot of more bonding can take place. So usually they would give you like what is hydrogen and oxygen? Well, hydrogen and oxygen they won't give you, they just give you the compound and ask you to write that name or write that this is hydrogen oxide hydrogen H2. So now let's look at nitrogen bromide 3. How does this take? What happens during this bonding process? Well, you have nitrogen. One nitrogen. Look at the periodic table. Nitrogen is. Look at this here. Right. So nitrogen is 1, 2, 3, 4, 5. Nitrogen has 5 in. Nitrogen has 5 electrons in its outer shell. Bromide has 1, 2, 3, 4, 5, 6, 7. Bromide has 7 electrons in its outer shell. So there's 3 bromide, so multiply by 3, so this would have 5, would have 1 nitrogen, so it's 5 electrons plus bromide is 7 3 is at 21 electrons. So in total 21, 22, 23, 24, 25, 26. So you count up the amount of electrons in both of them because that's the ones you want to distribute. Because the electrons would move around so that they want to find stable outer shells. So now the one that's in a bromide has nitrogen has 5. Bromide is more, there's more bromide, so the one that's more would most likely go around. So the one that's less would most likely go in the middle. So you have nitrogen in the middle, and you have 3 bromides, right? Bromide, bromide, bromide. To form stable octams, they would have to be bonded together, like one from here, one from here, one from here, one from here. Right, so now the 1, 2, 3, 4, 5, 6. So it takes 6, so you're left with 20 electrons to distribute. Each need in this bromide, anything that's more than 2 in the outer shell needs to be 8, because it's 2, 8, 8. Right? So bromide can need 8, these two can need 8. So you have 20 to distribute, so you put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So are they stable? They all have 8 in the outer shell. Let's see. One, 2, 3, 4, 5, 6, 7, 8 for nitrogen. 1, 2, 3, 4, 5, 6, 7, 8 for bromide. 1, 2, 3, 4, 5, 6, 7, 8 for bromide. 2, 3, 4, 5, 6, 7, 8. And that's it. That's a covalent bond for bromide. So you see what's going on there? The covalent bonds, the electrons come together in such a way that they all share, and you get nitrogen bromide 3. This is 3 bromides bonding with 1 nitrogen in a stable configuration, where all share to form a stable configuration. Okay, so look at this example. Oxygen. How would oxygen is a covalent bond. We know this because oxygen is a non-metal. It's 2 non-metals, 2 oxygen. So it's a covalent bond. So how does that take place? Well, oxygen is 1, 2, 3, 4, 5, 6 electrons in its outer shell. So oxygen has 6 electrons, but it's 2 oxygen. So by 2 is 12 electrons in total. So that means we already have the structure. If you have 2 oxygens and they're bonding together, then you put the 2 bonds, 1, 2. So now you have 10 to work with. So you write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So you have almost the same amount of this. So do the formula 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. No, they don't. What you can do is you could actually take another one and put it here. 3, 4, 5, 6, 7. You could actually take another one and put it here. Take another one and put it here. So what's you left with? Is this 1, 2. So we're out of electrons. We don't have any more. We have 10 when you do it. What we could do is we could put this here. So you know you can, instead of being 2, you have 1, 2, and you want to put here. So now you have this. So you count it. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. He has 8. He has 1, 2, 3, 4, 5, 6, 7, 8. You see he has 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So now it's stable. So that's how oxygen will look. You could also write it like this: double bond with electrons. That's how oxygen bonds. This looks. That's how we have O2. This covalent bond. Another thing, when you have the electrons, you try to put them as far away from the middle, because they repel each other. So the way you would draw the final product would be there. 2 here and the 2 here. Try to put it as far away from the middle. So last one, nitrogen 2. How does nitrogen 2 look? Well, you have 2 nitrogens. Each nitrogen has, on the outer shell, has 5 electrons. So anything that have 5 in the outer shell, we need 8 to be complete. So keep that in mind. There's 2 nitrogens, so it's 5 2s are 10. So you take the 2 nitrogens, you want to distribute the 10 electrons. So you put the 2 here in the middle first, so they both, 1 from each, so they can bond. Then now you have 8 electrons to work with. So put 1 there, 1 there, 2, 1, 2, 3, 4, 5, 6, 7, 8. So would they form a octane bond? The answer is no. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So you'll have to take, if it's 6, then you take 1 from here, 7, and you get 8. So you take 1 from here and take 1 from here. So you get an N. You get 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Right, so you had 2 there, 1 there, 1. So now you put these 2 here, and then you check it up. So now you get 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So you have 7. So you could actually take another one from here, another one from here. So when you take another one from there, you get N, 1, 2, 3. Take the 2 from there, and you take 1 from here. So you take, right here all you have 2. So you take 1 from there, take them from here. Right? So now you count that up, and you get 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So you get a stable. That's how it is. So this is called a triple bond. Takes 3 of each electron to form, and you've tried to put this as further away. And that's it. That's what happens. So they see how they're sharing, how they're stable when they share it. So that's what happens during covalent bonding.